Extending the life cycle of buildings and building materials is of paramount importance in mitigating the climate crisis. Wood has the potential to store carbon in building materials and products for centuries. This is essential as demand for housing skyrockets.
So we are going to need new buildings, and we know that wood can play a strong role here.
However, there is much room for improvement in the recycling and life cycle design of wood products, especially in the construction industry.
I think in general, we, as engineers, we have a quite large responsibility about our environment. And I mean, we all know that our buildings are a large share of our CO2 footprint and other environmental burdens. And so we really should start to design our buildings in a way that, in multiple ways, more efficient.
Construction and demolition waste is the largest waste stream globally, accounting for 40% of the total waste volume on average. Only 30% of all wooden construction waste is recycled, and the remaining 21 million tons goes to waste every year in Europe alone. At the current rate of use, it corresponds to over 9 years' worth of wood needed for wood construction in Finland. There are many challenges in recycling wood, one of them being the hybrid nature of buildings.
Building always contains multiple materials. It would be very inefficient to have an entire building for one material, so at the end it will be a hybrid product out of many different kind of components.
When we create hybrid materials, hybrid systems, we kind of introduce complexity, and that makes it a lot more difficult to then recycle or reuse those in other forms. For me, it's very important to be working with designers and with architects to look at these issues, also with structural engineers. I think no one discipline is going to have all the solutions to this kind of issue.
At Aalto University, a multidisciplinary group of researchers is working to improve the life cycle thinking in forest-based products in the construction industry.
I think we can say that for the last century, researchers have been probing wood as a material. We still don't know that much about wood still, even after all that time, and that's just fresh primary wood. So when we're taking this other material that's had another life, and we don't necessarily know what the life has been, we don't know enough about its properties, its characteristics in order to reuse it.
There are many open questions because if you look at the current situation, the process they use to demolish a building and to process wood is meant for energy recovery rather than reuse and recycling.
The fundamental material science research in this area aims to understand the properties of aged and used wood.
When we talk about a piece of wood that's been, let's say, taken from a demolished building, it will have undergone an aging process, depending upon what function it had in that building, if it was a structural member or if it was non-structural. It'll also depend upon things like whether it's had any coatings or any treatments. It will depend on how it's been fixed, whether there are any glues, metallic fixings, whether it's been made as part of a system, so whether it's got insulation attached to it or plastics. So there's a whole bunch of different things that can influence the quality of that material.
The quality should be assessed, and there are many applications according to the quality of wood, but after the demolition they crush it in smaller pieces in order to make the basically transportation to waste management site much easier, which is against what we want for use and recycling. So I would say there are many applications like CLT, LVL, like even direct reuse or particle boards or anything rather than energy recovery.
In addition to the study of the properties of used wood, Hughes and his team also approach the challenge on a systemic level.
I think the whole life cycle is the key point, because when we're thinking of life cycle of product, we usually think it from the material to when we maybe dispose of it or then reuse it afterwards. But when it's wood we're talking about, then the whole life cycle is actually already, we should have a focus also with the forests there and the use of forests, which we use as a material.
The life cycle perspective emphasizes the importance of design. This can also be promoted through a better understanding of the material.
We have a concept called design for disassembly or design for deconstruction, where in the design phase of a building, you think that this building someday in the future wants to demolish, and instead of like normal demolition that you crush it with big vehicles, you will basically disassemble it into individual pieces or into wall units or to like different units, and then you will use it in a new building or in a new material form.
To tackle this challenge, a new research project called Duet is focusing on the circularity of wood building elements. Apart from developing processes, design, and grading, the reuse of material faces challenges such as acceptance and feasible business models.
How do we manage this waste stream? How do we process it? How do we then market that? How do we create business from it and things like that? So I don't think we're far away from it. It's just, I think, building the right circumstances in order to make it happen.
This area of research is pivotal. Alongside other measures, such as extending the lifespan of buildings and reducing new construction, recycling and reuse can play an important role in reducing the impact on the carbon footprint of the global construction industry.